In this lesson, we will examine a technique called factoring. Now, in previous lessons, we took products such as this one and expanded them by multiplying the terms inside the parentheses by the term outside the parentheses. We also expanded products of two binomials using the FOIL method. We are now going to reverse this process. We will take an expression such as this one and rewrite it as something times something else. We will also learn how to take polynomials such as this one and rewrite them as the product of two or more expressions. When we take an expression and rewrite it as the product of two or more expressions, the process is called factoring. Later in this module, you will see that we can accomplish many things through factoring, so we must be sure to master this skill. Now we're going to study three primary types of factoring, the first of which is called greatest common factor or greatest common divisor factoring. Here's how it works. We first want to find the greatest common factor or greatest common divisor of all of the terms in an expression. To do this, we will examine members of the same family. So beginning with the coefficients, we have 14 and 21, and here the greatest common factor is 7. Next, we will examine the x's. We have x squared in the first term and x in the second term. So the greatest number of x's that they have in common is 1x. So the greatest common factor of the terms 14x squared and 21x is 7x. At this point, we must determine the expression that needs to be inside the parentheses such that 7x times this expression expands to equal 14x squared plus 21x. So, for example, what must we multiply 7x by to get a product of 14x squared? Well, 7x times 2x equals 14x squared, so we will add that here. Next, we need to determine what to multiply 7x by to get a product of positive 21x. Well, 7x times positive 3 equals 21x, so we can add that here. We have now factored 14x squared plus 21x. It is equal to 7x times 2x plus 3. Now, how can we be sure that we have factored this correctly? Well, we can always take our product here and multiply it out. When we expand this, we get 14x squared plus 21x, so we must have factored correctly. Okay, let's try another one. First, we need to find the greatest common factor of the coefficients. Here, the greatest common factor of 6, 12, and 33 is 3. Next, the x's. These terms have at most one x in common. So the greatest common factor of the three terms here is 3x. At this point, we must determine the terms that need to be inside the parentheses. So the first term here must be 2x squared, since 3x times 2x squared is equal to 6x cubed. The next term must be negative or minus 4x, since 3x times negative 4x is equal to negative 12x squared. And finally, the last term here must be positive 11, since 3x times positive 11 is equal to positive 33x. We have now successfully factored 6x cubed minus 12x squared plus 33x. And if we wanted to, we could verify this by expanding the right-hand side. To factor this next expression, we will first find the greatest common factor of 15, 20, and 5, which is 5. Next, the x's. These terms have at most x squared in common. So the greatest common factor of the three terms here is 5x squared. Now we must determine what goes inside the parentheses. So the first term must be 3x cubed, since 5x squared times 3x cubed is equal to 15x to the power of 5. The next term must be negative or minus 4x, since 5x squared times negative 4x is equal to negative 20x cubed. And finally, the last term must be positive 1, since 5x squared times positive 1 is equal to positive 5x squared. Okay, one last example. Here, the greatest common factor of 4 and 10 is 2. The greatest common factor of w and no w is nothing, since the second term here does not have any w's. The greatest common factor of x squared and x to the power of 6 is x squared, and the greatest common factor of y to the power of 4 and y cubed is y cubed. So the greatest common factor of both terms here is 2x squared y cubed. Now the brackets. Inside the brackets we have the following, and I will leave it to you to confirm this. Okay, to summarize. To perform greatest common factor factoring, first find the greatest common factor, or divisor, of all of the terms in the expression. Then place the greatest common factor in front of the parentheses. And finally, determine which terms must be inside the parentheses in order to get the desired product. In this lesson, we will examine a type of factoring called difference of squares factoring. To learn more about this technique, we will first make some observations. Let's see what happens when we multiply two binomials where the binomials are identical except one binomial has a plus sign and the other binomial has a minus sign. To expand these products, we will use the FOIL method. So for the first product, we will multiply the first terms to get x squared. When we multiply the outer terms, we get negative 3x. When we multiply the inner terms, we get positive 3x. And when we multiply the last terms, we get negative 9. At this point, when we simplify, we can see that the two like terms, negative 3x and positive 3x, cancel out, and we are left with x squared minus 9. In the next example, when we apply the FOIL method, we get the following. When we simplify, we can see that negative 10x and positive 10x cancel out, leaving us with 4x squared minus 25. One more example. Applying the FOIL method here gives us this. When we simplify, the two middle terms cancel out to give us 49x to the power of 4 minus 1. Please notice that when we expanded and simplified each of these products, the first term is a square, the last term is a square, and in all three cases we are subtracting one term from the other. In other words, each result is a difference of squares. From these examples, we can say that the generic product a plus b times a minus b will always equal a squared minus b squared. Given this rule, we can expand this product by first taking 3m and squaring it to get 9m squared, and then we will take 2y and square it to get 4y squared. From here, we can take this result and use it to help us factor expressions. To do this, you may find it useful if we reverse the order of this equation. Okay, now let's say we want to factor x squared minus 16. We should recognize that we have a difference of squares here, since x squared is a square since it is equal to x squared, 16 is a square since it is equal to 4 squared, and this is a difference of squares since we are subtracting here. As such, we can factor this expression to be x plus 4 times x minus 4. Similarly, this is a difference of squares, since 4x squared is equal to 2x all squared, and 9y squared is equal to 3y all squared. So we can factor this expression to be 2x plus 3y times 2x minus 3y. Here's another difference of squares. Please note that x to the power of 6 is a square since it is equal to x cubed times x cubed. In other words, x to the power of 6 is equal to x cubed all squared. Also notice that 25 is a square since it is equal to 5 squared. Since this is a difference of squares, we can factor it to be x cubed plus 5 times x cubed minus 5. Here's another difference of squares, and we can factor it to be 7x squared y plus 1 times 7x squared y minus 1. Okay, here's one last example. Now be careful with this one. A common mistake to make here is to classify this as a difference of squares. While x squared is a square and 81 is a square, this is not a difference of squares since the two squares here are added. So we cannot factor this expression in any meaningful way other than to write it as 1 times x squared plus 81, which doesn't really help us at all. Okay, let's summarize. Be sure to watch out for expressions that are differences of squares. If you encounter one, you might want to consider factoring it to help you gain some insight into the particular problem.